Our next unit is going to be on models of the universe. So when people look at the sky, they saw things like that the planets were lining up with different constellations of the zodiac, and they wanted to explain why. So the models of the universe have to explain the things that we see. For instance, the apparent motion of stars. Stars seem to circle Polaris at 15 degrees per hour each minute. And then we have to explain the apparent motion of the sun. So the sun does the same thing. The sun moves at 15 degrees per hour. Okay, but also ends up with different constellations of the zodiac over the course of the year. And then the sun also appears to change size. And the size, we can call its apparent diameter. And then the planets move at 15 degrees per hour. Planets travel through the zodiac like the sun. The planets do something the sun doesn't do. We call that retrograde motion. And the planets seem to change size as well. So the first type of models we're going to look at are geocentric models. In geocentric, geo stands for Earth. So geocentric means Earth centered. So the first model we're going to talk about is Aristotle's model, and it was very simple. Okay. In it, sun, planets, and stars all circle the Earth in perfect years. So here's a picture of that. So we got the Earth in the middle and everything going around the Earth in these perfect circles. And what does this model explain? Well, it does explain that the stars and the sun and the planets move at 15 degrees per hour because they're just going around here, and you can imagine them going around, all of them going around about 15 degrees per hour. It also explains the sun moving through the zodiac. All right. Right now, the sun is lined up with these stars. If it's going a little bit faster than the stars, then it's going to come over here, right? And it's going to line up with some of these stars. So over the course of the year, it's going to line up with different sets of stars. And for the same reason, it explains the planets moving through the zodiac. Right now, Mars is lined up with these stars. A few days later, it might be lined up with these stars. It doesn't explain retrograde motion because the planets are just going this way counterclockwise and they would never turn around and back up. It doesn't explain the apparent change in size of the sun because the sun is always the same distance from the Earth. It's always going to look like it's the same size. So we had to fix this model because it doesn't explain those things. So the next person who came around was named Ptolemy. In his model was still geocentric, but Ptolemy added epicycles. And epicycles are little orbits on orbit. And that doesn't make a whole lot of sense until you see a picture of it down here. So in this example, here's the orbit of Venus. Okay. But Venus doesn't actually sit on that orbit, it's set on this epicycle. And it goes around this as the epicycle is going around here. So Venus would be going like this. And I've drawn that in for Jupiter here. Jupiter would make this corkscrew shape because it's going around this little epicycle, okay, as that epicycle is going around. And let's see what that explains. Just like the other one, we got the Earth in the middle and the planets are going around, so it does show those things moving. All right. Again, if the stars are over here, the sun is going to line up with different sets of stars, so it does show the sun moving through the zodiac. All right. The planets moving through the zodiac, same thing. Mars right now is over here, lined up with these. Later on, it will be lined up with some other ones. So it does explain that. Now, the good thing about this one is it does explain retrograde because as Jupiter's going around this way, sometimes it's on this side where it appears to back up. So here it's going forward. Oh, there it's backing up. And then it's going forward again. Then it's backing up. So it does explain that. All right. The change in the apparent size of the sun, it doesn't. Here the sun is just going around. It's always the same distance away, so it wouldn't really explain that. But it does explain the change in size of the planets because sometimes Jupiter's closer, sometimes it's farther away. That would make it look like it was getting bigger when it's closer and smaller when it's farther away. Now, there were other problems with this model, okay? It did not explain or did not predict the positions of the planets in the future very well. Okay, Ptolemy might have been able to tell you where the planets would be in a day or two, but he wouldn't be able to tell you where they would be in several years. Okay, and it became very complicated. Okay. To explain where the planets would be in the future, to predict them better, they kept adding cycles on cycles. And it got just to be a giant mess.